Hey guys, today we're going to dive into the world of histograms. So what I would like you to do first is to just tell me what you think a histogram is. Do that without Googling it, looking up the answer anywhere on the internet or your textbook. Just write down what you think. All right, so let's go ahead and jump in. So for histograms, here's an example of one. This one is a graphical display of the age at first marriage of some males that were surveyed. So it looks very similar to what you might have seen as like a bar graph. It does have a couple of differences, but this is an example of one. So you can see here's our classes or intervals at the bottom. The frequency is on this side, and then we've got these bars to represent the frequency of each category there. So based on this one, it looks like age 26 to 28, somewhere around there, is the normal, but there's also a spike here and around 30 to 31. So maybe a bunch of guys realize at 30 years old, I'm getting kind of old and should get married, something like that, right? So interesting data display there. And we're going to look at a few different examples of this today. We're also going to talk about the shape of distributions. This one has a particular shape, and we're going to learn how to describe those shapes of the data. So first of all, just a few features of the histogram. One thing is it's a visual display, or like I could think of it as like a graph in some sense, of a frequency table. Typically on the x-axis, or the horizontal axis, we're going to put the class boundaries, like this last one had. It actually doesn't have the boundaries so well. It's more of just the classes. You'll find a lot of different histograms. There's no sort of pattern on this. They're not all the same. Sometimes they'll put the midpoints there. Sometimes they'll just put the class widths. It's a little bit confusing on this because you can see the numbers are doubled up. So if someone was 24 exactly, it's not super clear on which category they'd be in. So this one could definitely be improved. So generally you'll put the class boundaries or the midpoints, I've seen both, on the horizontal axis, and then the frequency is always on the vertical axis. Definitely always important to put titles on the top and then on both axes as well. And then one big thing here is that the bars are touching on a histogram, and they always have to be equal width. Bars must be touching and must be equal width. That's what makes it a little bit different from a bar graph. A bar graph, they aren't necessarily always touching. But in a histogram, the intervals always touch each other. There's no gaps in the intervals, so the bars should always be touching. The only case where they wouldn't necessarily be touching would be if you had like a zero. So let's say you have one here and then one here, and then you actually have a zero interval. It won't look like they're touching, but in fact there is one down here. It would just sort of be at zero. All right, so those are just some basic facts. A couple examples here. You can see it. One is a good example, and then one is a bad example. These are both supposed to be histograms, but you can probably identify which one is not correct here. The problem with this one is that the bars are not touching. So they didn't draw that one correctly, but it is supposed to be representative of a histogram. This one is a little bit better here. You can see they use the midpoints instead of the boundaries. That's okay. Again, there's no industry standard, if you will. All right. So both of these distributions and all of them that we're going to look at, a distribution is basically just a graph. I use that word distribution. These apply to any different distributions. We're going to talk about something called a Pareto chart, some different things that will have this shape as we go. So we're going to outline the different types of shapes. And when you do your assignment, you're going to be identifying the shape of your given distribution. So the first one is a symmetrical or mound-shaped distribution. And that is the case. I'm going to draw a little example of these. If it's symmetric on both sides, sort of when you fold it in half. So you got your highest numbers in the middle here. They don't have to be exactly the same, but you sort of go down as you go. You could have one that's a little bit spiked in there, right? And then same would be on this side. Obviously, my bars are not equal in this case, but you get the idea here. Both sides are about the same when you fold it. If you were to fold it in half, they would be about the same. So that's called symmetrical or normal shape, mound shape. Now, another description we'll use this one is normally shaped. Because later this year, we're going to talk about something called the normal curve, and it has this basic shape. So if we say something is normal, that's what we mean. Another possibility is a uniform or rectangular shape. And that's the case if everything has approximately an equal frequency. So we've got, everything's about the same straight across. This one's pretty unusual, but, if it was about the same like this across, sort of has a rectangular shape. So it's uniform, but everything has about the same frequency. There's not really a lot of difference. That would be a uniform or rectangular shape. Okay, the next one is skewed left. And that is the case when we say we have a longer tail on the left. You could also say left skewed. Might say that as well. Skewed left or left skewed. That looks like this. So you got your distribution. It's kind of short on this end, and then it builds up, and it's higher over here. So that would be left skewed. There's more values on the right side. The opposite of that would be skewed right or right skewed. And that's if we have a longer tail on the right. So same idea, except we got our high values on the left side. It's kind of the opposite of what you might think. At least that's how I think of it. And then a longer tail on the right. Like that. That would be right skewed. Make sure you're very familiar with those two terms. They're not difficult, but it is easy to get them mixed up. And lastly, something called bimodal. Bimodal literally means two modes. Bicycle, two wheels, right? Bimodal is two modes. And this could also be referred to as U-shaped. And in bimodal frequency, there's two classes with the highest frequency, and they have to be separated by at least one class. So for instance, maybe we've got some values here. We got a really tall one here, and then we got some in the middle. And then we got another big one here that's the same. And you can see it has a U shape there. You've got two, this one and this one, that have the same frequency. So we'd say it's bimodal or U-shaped. All right. Next we are going to be doing is histograms on the graphing calculator. So given the digital format of this course, we're not going to be drawing out a lot of histograms on paper. One, you probably don't have graph paper. Two, it is a little bit challenging to get exactly equal intervals. We might do this with Pareto charts at some point where we draw them out. But for now, we're just going to do them on the calculator. And that is something that we learn anyhow. And in today's technology, most graphs that you're going to make, you're actually going to use some sort of computer software. So that's what we're going to do. We're going to be using our graphing calculators. So if you have one, now would be a good time to get it out and follow along as I do this. And I'm going to refer back to this list. Feel free to take a picture of it or whatever. The first step you're not going to have to do every time. It's just going to be the first time. But I'm going to pull up my calculator here and do the best I can to show you. I'm going to show you on the webcam the best I can. But most likely, when you turn on your calculator, first thing you're going to do is hit second and then stat plot. So second, stat plot. And that's kind of hard to see. Hopefully you see this screen. Can't really tell what you're seeing. All right. So hopefully you see that screen. And then most likely it's going to say plot one off. So you're going to hit enter on the one where it says plot one off. It could say on, but either way, click enter on the first thing. You're just going to hit enter. And then you'll see this menu here. What you're going to want to do is turn it on. So you're going to hit enter on the on. So it switches over to on. And then for type, you're going to move down and you're going to move it over to the little bars there. That's actually histogram. So you're going to hit enter on that and select that. So hopefully you can see that. All right. And then we can just hit second quit. Now what that's done is it's turned on your histogram. So the next thing you're going to do is stat and then hit enter on edit. And you should see some lists come up. It should say L1, L2, L3, etc. So we're going to be editing list 1. What that means is we're going to type all of our data into list 1. So, well, we're going to take a pause here, and we're going to need some data. So let's go to the next slide. So this represents the number of COVID deaths per 1,000 people. What I did is I went to the CDC website, and I'll show you here. Went to the CDC website, and it shows you the number of deaths per 1,000 people. So big states like Texas, California, they're obviously going to have more deaths because they have a lot more people. So you can see their total cases, cases per 1,000 and cases per 100,000. So that's where these color codes come from. States like Wyoming, where they don't have that many cases, they only have 8 deaths per 1,000 people. Texas has 54 deaths per 1,000 people. Louisiana has 118 deaths per 1,000 people. So there's a big difference in these. The biggest one you'll actually find is New York City. They actually split up New York and New York City in this. New York City has 283 deaths per 1,000 people. If you remember at the beginning, they had a really big problem there in some nursing homes with COVID deaths. And so theirs is hugely spiked, and they actually looked at that as a separate case than New York in general. As you can see, Ohio is at 41 deaths per 100,000 people. And what I mean by that is if we have 100,000 people, you would expect 41 of those people to die from COVID. So what I did is I took all this data from all of these states, and I put it in our PowerPoint here. It's actually in order already. So this top one's New York City. And there's actually 52 data values because New York City is different than New York based off of this. And also Washington, D.C. is a separate case as well. So there's 52 data values. What I would like for you to do is pause this. That's what I'm going to do. Type all of these into your list 1. Okay, so at this point, you should have them all typed in. I've got all of mine typed in there, and there should be 52. So your 50-second value should be there, and then below that would be 53. This is a good way to check that. So after we've done that, the next step, so that was step 3, type all the data values into list 1. We are going to do the window function. So if you'll see at the top, where in the grays it says window, right there it says window. So do that. And you're going to change the xmin, the xmax, and the class width. Okay, so xmin is just going to be your lowest value. In this case, it's pretty easy. It's 7. Xmax is going to be 283. And now the next one is the XSCL. That's like your X scale. Think of it in that way, your X scale. And for that one, you're going to have to calculate the class width. So I didn't actually tell you in this one how many classes to do. Let's say we're going to do 10 classes. So for XSCL, we're going to do our class width, which is the biggest minus the smallest. So 283 minus 7 over the number of classes. So you do have to do that calculation on your own. 283 minus 7 divided by 10. That gives you 27.6. And we're going to round that up to 28, as always. So then on your calculator, you're going to type that in for your XSCL. So again, you're back in window. Should have a window, your xmin, your xmax, and then for your XSCL, you're going to type in 28. It'll just make up one if you don't tell it what you want it to be. So you got to put that in. So I know that's hard to see, but hopefully it's helpful. All right, then you're going to graph it. And then depending on what your zoom looks like, you probably just get something like this, just your coordinate plane. We want to be able to see our graph. So what we're going to do is hit zoom, and then you're going to go down to the one that's number 9, which is zoom stat. And you're going to hit zoom stat, enter. And then you should get a very nice little graph there that looks like this. Now that is your histogram. You can see this one has a very distinct shape. There's a lot at the very beginning, but then there's very few towards the end there. And that's a good thing in terms of this graph, because we're talking about COVID deaths per 1,000 people. So that means a lot of states are low, and there's a few that are really high up there. This one's not maybe the best to graph because you can't necessarily see all the bars, but it looks like we're missing 2 of them there towards the end. So the first few are pretty clear there, and then we're missing a couple. So what we're going to do is we're just going to draw a sketch of this shape. We're not going to like draw the histogram out with, all of our labels and everything. We're just going to draw a sketch of this shape using our graph. So what I want you to do is, again, just do your best job to sketch this. And this is what I want you to do on your assignment as well. So we got a very high one up there. It doesn't have to be exact. We're just sketching the general shape. Try to make sure the bars are pretty even, but again, they don't have to be perfect. There's one here, and then we skip a couple, and it looks like we got another one down here we can barely see. All right, so that's a pretty good illustration of what a graph looks like. Again, we're just talking about the distribution shape at this point. Don't worry about your labels and all of that for right now. So that's what our distribution looks like. And now we want to describe the shape. So this is definitely one of those 3 and 4 we talked about, right? So this one has a very long tail on the right. So that's what we call skewed right. So for your assignment, what I'm going to be having you do is this very thing. I'm going to want you to plot this in your calculator, draw just the sketch of what it looks like, and then identify the distribution shape. All right, and this does make sense because if you look at our data up here, we have 283 sort of throws off everything. That's something called an outlier. It really throws off everything, so it groups all of the other data pretty closely there at the beginning, because there is such a wide disparity there at the end. All right. So we're going to do one more example. On this one, we're going to look at the heights of the last 25 presidents. So here's kind of a funny graphic here that shows Abraham Lincoln was the tallest president. Trump is not far behind. But I'll show you the website here where I got this from. And that's kind of a cool graphic. It like shows the presidents in descending order there. So the smallest president was James Madison. He was the 4th president. He was 5'4". Abraham Lincoln was 6'4". So Abraham Lincoln was a foot taller. So we're going to look at just the last 25 presidents. And we're going to do the same thing we just did. So I'm going to pause it again. You take a minute. What you're going to do is just go back to your list. So you're going to do stat and edit. And you're going to just replace all of list 1. Now, one thing that you are going to want to do is make sure all the extra data values are cleared out. So what I would do first is just go to stat, edit, enter. And then on list 1, you're going to want to clear that whole thing out. So you can actually just on list 1 up at the very top where selected, hit clear and then enter. And it should clear everything out of there. If not, you got to go through and do everyone individually. So we're going to pause a second here. enter these data values. Actually, pause your video and enter them, and then I'm going to pause this because otherwise it'll go away. Sorry, I should mention that we're going to do the centimeters, the height in centimeters. So you're going to be entering that column, the centimeters height. So do that now. Okay, so hopefully you've got those entered. Again, make sure there is exactly 25 of those. So your 26th one should be empty. After that, you don't want any values below that, so make sure that's the case. So then the next thing we're going to do is go ahead and go to our window and put in the Xmin, Xmax, and XCL, which means we also need to determine the number of classes. For this one, let's do 6 classes. So we're going to put in our Xmin, find our minimum value there, which I believe is 168. I don't think I see any below that. And then our max, I think, is there's 191, but that's the max. Yep, all right, and then XSCL, we need to do a quick calculation before we do that. So we need to do 191 minus 168 divided by 6. And we get 3.83. So we're going to round that up to 4. So then we're going to go back to window. And then for XSCL, we're going to type in 4. And then we can go ahead and do graph. You might again need to do zoom and then stat. And you'll get a graph that hopefully looks like that. So let's go ahead and draw that. Again, it doesn't have to be amazing, but try to do a fairly accurate trail of this. At least proportional. Try to make sure your bars are equal in width. When you actually do one of these by hand, you have to either use graph paper and be really specific or measure each of the bars, which is not so easy. All right. So this one, the closest thing that you could say as far as the description of the shape of this, think about it for a sec. The answer would be, get back to our slides here. It's not letting me go back. So if you scroll through these, symmetrical, uniform. If we had to put it on one of these, the answer would be approximately symmetrical. It's close to normal. You got the median in the middle. The median means, or the mode, sorry, and the most ones in the middle there. And then it does pretty much tail out from there. Now there is kind of a couple outliers in that this bar here is a little bit higher, right? Same with this one. But in general, we got the highest in the middle, and then it does sort of go out from there. So we could say that this one is symmetrical or mound-shaped or normal. That's the best description we could do for that one. So again, on your assignment, you're going to have a couple of these where I want you to graph them on your graphing calculator. Don't skip that step. It is very important that you know how to do that. Draw what you see and then describe the distribution. And as always, reach out to me if you do have additional questions. Thanks.